All right. Good evening, everyone. Once again, I just started recording the call, and welcome to Starknet Security Bootcamp. We um we began yesterday for those who are probably new, talking about Starknet architecture, and today we're going to be looking at some basic security um, basic vulnerabilities. We're going to be looking at why security is important and how we can, in general, build safer protocols. Okay, so for those who were probably not present yesterday, my name is Darlington. Darlington, I am the ecosystem associated agent. I also work with the team at Starknet Africa. Um, You can find me on Twitter at Xerex Darlington. All right. So for the agenda, the first thing we're going to be looking at is we're going to be looking at what's blockchain security. We're going to be looking at why security is important to blockchains. We're going to be looking at common security vulnerabilities. We're going to be looking at building safer protocols. We're going to be looking at tips to becoming like a better auditor. Yeah, so what is blockchain security? I guess it's not a concept a lot of us are new to, considering like guild audit is a security focused company, right? So but just for people who are probably hearing about blockchain security for the first time, when we talk about blockchain security, right, we talk about the combination of cyber security principles, security tools and best practices in order to basically mitigate the risk and avoid malicious attacks and unauthorized access while operating on blockchain networks. So, why is security important to blockchain? So, why is this very important? Why is your journey to becoming a security auditor on Starknet super important? Why is it something you should pursue? So we know that over the course of years since the inception of blockchains, the number of protocol hacks that have been recorded and the amount of money which has been lost with each hack has been mind blowing. Possibly, if you are probably not aware of this, right? There's direct dashboard which are probably going to go through. You could also follow people like Zach XBT on Twitter who talk about these things like on a regular, right? You know that we've lost a lot of money due to very little mistakes or very minute mistakes most protocols have made, right? And this in itself is a good indicator that more than ever, we need superheroes, we need blockchain Batmans, we need auditors, we need security experts, people who are willing to go to lens to see that these protocols are safe to use. Just if you've probably not heard about any, we could check out the Rex.news dashboard. So I will just want to confirm you can say this right. Yeah. So let's just check what's it called? Let's check the leaderboard. So as you can see, there are about 96 hacks that have been recorded thus far. And as you can see, the running network, which was probably the one with the most money lost, this was $624 million. This happened in 2022, right? And the protocol lost a lot of money to the hack. There's this one which lost $611 million. The one for BNB Bridge about $586 million. And you will notice that a lot of hacks has happened on bridges and a whole lot of other like smart contract protocols, right? So this in itself like shows the reason why we need smart contract auditors, we need security experts, like I usually call them blockchain superheroes. We need people who would really put in their efforts, right, to see that these protocols are as safe as they can be for normal users who are interacting with them. So we're going to start with looking at common security vulnerabilities on Starknet. We're going to explore a few vulnerabilities that are peculiar to Starknet, which you need to understand as a security auditor, basically. The first one, which is something like a lot of people usually miss out on, right, is access control. So access control vulnerabilities occur basically when a smart contract function are insufficiently protected, thus allowing unauthorized actions. Access control vulnerabilities can result in unexpected behavior and data manipulation. So let's say this little contract, for example, right? Now let's assume this is an year 721 contract or whatever it is, right? And we have this function means tokens. Now originally this function means new tokens, right? Let's say it's an year 20 tokens or whatever, right? And it's responsible for minting new tokens into like the ecosystem. Now imagine if this token, as you can see here, if you look at this function, which I believe like a lot of us are not new to carry, right? If you take a good look at this function, you can basically see that it's not gated. So when you come to the function mint tokens, we just when you call this function, sorry, when you call this function, it just basically goes ahead to increase the total supply, right? Now this function without an access control basically means that any user at all can call this function, thereby posing a very big risk to like the protocol in itself, because it means that users can mint unlimited amount of money into like the ecosystem. Now this is a more secure version of this code. So as you can see here in this particular version, please, if you can't, like if it's not too bold, or you can always ask me to like zoom in. I don't know if we can see this. If you can't, you can just ask me to zoom in and I will. Okay. Yeah, so this particular function now, as you can see, now we add an access control. First of all, we get the caller address, and the get caller address basically is a syscall from Starknet, which basically gets like, think of it as Ethereum's message sender for those of us who are familiar with Solidity. Now we get the caller address, and we use an assert statement to ensure that the sender is equal to like the owner. As you can see now, this contract has an owner, and only the owner can is responsible for minting tokens. So we add this assert to ensure that we enforce this, that only the owner can actually mint tokens into existence. So what assert does basically is, if the statement within the assert does not equate or evaluate to true, right, the whole function is going to basically revert. It's not going to go through. And as you can see here now, this is now a more secure code, because now only the owner of the contract is able to like mint new tokens into existence. Another very common vulnerability, right, which um, we encounter on Starknet, right? Of course, you also encounter this on Solidity. These are like common vulnerabilities, right? Is the reentrancy vulnerabilities. Now, reentrancy vulnerability is a very interesting vulnerability and something you need to pay keen attention to, because it can cost you a lot of money if you don't. It arises when a smart contract basically calls an external contract before updating its state. This thus allows the external contract to recursively call the original function, potentially leading to unintended behaviors. A lot of protocols have been drained, like by reentrancy attacks. Now let's look at how this would work basically. So we have this code, which I hope all of us can see. Now this is the code basically. This contract basically, should I say, um assigns words to sorry about that. Yeah, sorry about that. Sorry about that. So like as I said, right, this is like a very simple contract, and basically what it does is it's assigns new swords to people who call the means one sword function. So let's say let's assume it's like a game, and when we call the means one sword function, a new sword is like assigned to you, something like that, right? So as you can see, what we do is just to explain the code, right? First of all, we get the caller address. That's the person calling the function. They want to check that the caller is part of the whitelisted. Sorry, a minute. Yeah, sorry about that. Um, as just to continue from what I was saying, right? So we first of all check that the sender is whitelisted. It's part of that's whitelisted mapping, right? And if the sender is whitelisted, what we do basically is we check the sword count, we deduct by one, and then as you can see, there's a mistake which was probably made here where we make a call to an external contract. We make a call to an external contract which calls the on received sword on an external contract, and afterwards we then like try to what's it called? We now try to update the mapping of the whitelist to show that okay, to false, to ensure that this user can no longer mint again. Now, when you want to implement such a contract, right, and you want to make a call and a call to an external contract, you need to ensure that you update the contract states before making the external call. Unless, let's see what can happen here. So in here, you can see that we call the unreceived sword on an external contract. So looking at this unreceived sword function, which you can see here, right? You would notice that let's say an attacker can basically create a contract like this with the unreceived sword method, and can basically say if the call number is less than 10, you can see he's running an array here. He wants to like keep minting one sword. And what's going to happen, which is where the reentrance comes in, right, is he now makes a call to the I sword contract, to the sword contract basically, and he comes here, he goes, it means another sword to like that color, and as you can see, he now comes back to the external contract again. Now he comes here and he calls it again. Now he goes back and he mints again, and it will just keep minting new words without updating the state. So what you want to do instead, right, is as you can see, you want to ensure you update the state first, the state of the contract, before making a call to like an external function. Now this is how you can actually prevent something like reentrancy. So these are very basic vulnerabilities which can actually skip our oversight and cause like a lot of issues. Another common vulnerability you would probably encounter on Starknet, right, is the overflow and underflow. So overflow and underflow vulnerabilities basically arise from assigning values that are too large or too small for a specific data type. So when they are too large, we call them and we call it an overflow, and when it's too small, we call it an underflow. So an example is considering the felt 252 data type. So the felt 252 data type is more or less like the native data type on Starknet. And with the inception of Cairo 1, in Cairo 0, right, everything was done in felt 252s. But with the inception of Cairo 1, there were like safer data types introduced, such as the in 256, in 128, in 264. That basically there was the introduction of unsigned data types. And if you notice, right, they usually advise, it's usually advised, it's the best practice, career practice, right, to ensure that you carry out calculation, arithmetic calculations using the unsigned data types, right, and try to avoid the failed to 52 data type as much as you can, because when you add or subtract values that are too high or too small, it can yield incorrect results. This is an example of a vulnerable code. So as you can see here, we are trying to multiply this by this by this. Now this value is going to, it's going to exceed the value of the normal field 252, and thus the result you're going to like get right is going to be it's going to be an incorrect result because he exceeds the field 252 data type. And that's why you should always stick to like unsigned integers. Next up, we are going to, okay, this is like a secure code, for example. So in here we use the low and the high unit 128 values, as you can see. And this is like a more secure way to write this. You could actually like check out this codes later. Then the last one, possibly the last vulnerability we're going to look at, there like a tons of them. You could probably like make more research after the class, right? But another vulnerability we're going to look at is private data on chain. No, it's I think one of the common misconceptions a lot of first timers make when they hear about zero knowledge rollups is assume that the zero knowledge there it means privacy, right? So currently there's just like the only private layer to like I currently know of, right, should be Aztec. And it in itself, I don't think it's not in production yet, right? And basically private rollups are usually called zk rollups because the zk in most rollups, right, is for scalability and not for privacy. So a lot of persons usually make that mistake of thinking that, okay, this is a zk rollup, it means that everything is private and I can basically store secret values, which is very wrong. So you should always note that storing secret values in smart contracts, Cairo smart contracts, presents a challenge because all the data stored on chain is publicly accessible even if the code is not published. So for example, let's say you decide to store a password using a constructor parameter. That's actually very wrong because like you're basically saying to the world, hey guys, hello world, here's my password. You can basically have access to it. So you should always keep note of that, right? There's no privacy, probably like with the inception of the L3s, people are going to be private L3s, but until then, Starknet is public, and every data you publish on it is accessible publicly. I don't know. Do we have any questions just before I proceed? Are there like any questions? Hey guys, okay. All right. So in the, oh, okay. Ethan asked the question. So let's start again. Let's go back. Yeah. So that's basically the maximum U into 128 value. So you can you would probably encounter this in like let's say an ERS-20 token or whatever it is, right? So when you're trying to get the maximum value that can fit into a U into 128, it's usually written like this. You could probably check out rival. I think this it's like it's 32 or something. So I really don't know why, but this. I've always known this to be like the maximum unit 128 value. You probably make research on like on it basically. All right. So in the absence of questions, the next thing we're going to look at is building safer protocols. So now we've talked about, we've explored common security vulnerabilities. We've looked at why blockchain security is important and why we need like security auditors like you. Now the question is, how can you build safer protocols on Starknet? So the first for me is I usually say this, right. As developers, you need to think more than you write codes, because it's before you basically as developers, you're just basically you're basically putting logics into codes, right? You are there's a certain behavior you're expecting and you're trying to put that into code. So you need to make sure you think about that particular logic, you think about the expected behavior, and probably anything that has possibility of going wrong, right? You need to like effectively or like properly understand and think about the logic you want to implement before you implementing it. If you understand the protocol you're trying to build, it kind of like helps you build it better and safer, basically. The second is writing tests. Now, this is something a lot of developers ignore, but the building safer protocols involve writing tests. You need to write a lot of tests, write tests and write tests and write tests, integration tests, unit tests. Ensure that you write as much tests as you can to ensure that you test everything that can possibly go wrong with the code. Writing tests gives you like is more or less like an additional layer of protection. So when you've written tests for your smart contracts, you know that okay, you've kind of like you can't just pass smart contracts you've written over to an auditor without actually testing to ensure that okay, from my own end, I feel like these are secure as it can get. So you need to write good tests before you let's say pass it to an auditing firm or a solo auditor to audit. Now, the third is implementing upgradability safeguards. So, this is something that has cost a few protocols a lot of money, right? So, most contracts are upgradable. Of course, when we got into blockchains and smart contracts, they told us that smart contracts are immutable and all. But of course, if you're going to build protocols that are going to be used by people, you need to ensure like it's like kind of upgradable, right? To ensure that you probably make changes to it from time to time. Now, it's important when you're building like smart contracts that are upgradable, you ensure that you implement safeguards, different safety guards or safety nets to ensure that only the right people can like upgrade the contract. You can do stuff like using implementing access controls to ensure that only like the owner of the contract or certain persons can like upgrade the contract. Of course, something that cannot be overemphasized, right, is using audited and well-maintained libraries. So don't just use anything you see or you pick up. You just start pick up and start using, right? You need to ensure that the libraries you're using are audited and they are maintained, well maintained from time to time. One of like the very popular libraries in the ecosystem is like the Open Zeppelin library. So you need to ensure you use like audited and maintained libraries. Then, of course, something else that is super important is ensuring you keep tabs with the latest changes to the Cairo programming language. So, one of the tricky parts about being a Cairo developer is you need to be ready to adapt to changes because it's a new language, and of course, since it's a new language, it means like there are a lot of room for improvement. So the language is changing as frequent. It changes, changing from time to time. It's changing from time to time. You need to ensure that you keep tabs with the latest changes. Always check out the new releases, the features it comes with, and check if there are like probably like vulnerabilities, previous or new changes brought up, and be ready to like just to be ready to act, something like that. So you need to keep tabs with latest changes to the programming language. Then finally, always audit your contracts. Never pass your contracts into production use without first of all passing it to an audit firm, or a solo auditor. I remember having a conversation with a friend, right, and he was like, "Wow, the amount of money people spend auditing contracts, like companies spend, like auditing contracts and all, is it like really necessary? It's a lot." And I was like, "Okay, you would really not know how important that is, right, until your protocol is in production, handling over $1 billion, right, and you get hacked, that's when you would know that okay, spending that few $1,000s you probably spend on auditing is the safer route to go, right? Because with smart contracts most times you're dealing with people's money, and when when money is involved, you know that you need to you need to put in a lot of effort to like ensure that the protocol is as safe as possible. Most times, probably when a hack happens in a website application, there might be likelihood that people do not lose money or stuff, maybe data is leaked or something. But web3 applications, any protocol gets hacked, millions of dollars are lost. So you need to ensure that you audit your contracts. Then we're going to look at some Starknet security tools for charts. So you've decided, okay, I want to become a Starknet superhero. I want to become that Starknet Batman. I want to become the Zack XBT of Starknet. I want to become the what's his name again? The SAMS is zone of Starknet. There are different tools you need to like have at your fingertips. So of course the security landscape on Starknet is not as improved or as developed as what we currently have on Ethereum, right? But it's coming up. For example, we have Cairo, which is a tool for smart contract developers to test security. So it functions both as a standalone tool and as a library. Do check it out. It's a very important tool you need to have at your fingertips as a Cairo developer. Secondly, we have Caracal. Caracal is like a static analysis tool for Starknet smart contracts. It utilizes the Sierra representation. You should basically check it out too. Then finally, we have TOTS. TOTS is a comprehensive Cairo or Starknet security toolkit. It includes analyzers, disassemblers, and the compilers. I'm encouraging you to actually check out these tools. Probably after the class, you'll find them a lot helpful on your journey into as a security researcher on Starknet. And yeah, thank you. I guess that's where would call it a day. So I don't know. Do we have any questions? Any questions? Yeah. So for this week, it's mostly going to be theoretical. But from next week, we're going to dive into writing tests. We're going to dive into writing tests on Starknet. And as we go further, we're going to start playing around with CTFs and a whole lot of other things. We have there are a lot of amazing speakers coming afterwards. We should yeah, and you definitely learn a lot. Okay, so can we have access to the slide? Yes, yes, yes. I would share it on the Discord channel just immediately after. And where can we find the recordings for this session? The ones from yesterday. I guess that would be up to David. They will probably pass my information on that. Then, are there any resources for further studies? Yeah, there are a lot of resources, and I think David has shared like a lot of them on the Discord. Just check out the Discord channel. Oh, this session classes with Starknet Base Camp 9. Sorry about that. Sorry about you could always check out the recording. The call is recorded. But I guess that will be it. Thank you so much, guys, for coming around. And if you have any questions, probably ask on Discord channel, and I'll try to answer. Yeah, see you next week, guys. Thank you so much. Take care. Bye, everyone.